Hello everyone, welcome to my YouTube channel Science Scholar Studio. In this video series, we are going to cover the Chemistry 0620 syllabus objective-wise. It will help you understand each concept clearly and effectively. Stay tuned with me till the end of this series to completely revise your syllabus and strengthen your concepts. In this video, we will be discussing elements, compounds and mixtures, atomic structure and the periodic table, and isotopes. An element is a substance made from only one type of atoms. Elements are pure substances that cannot be broken down further. For example, copper, sulfur, and oxygen are the elements. Compound is a substance made from two or more elements that have reacted with each other and formed chemical bonds. Energy is required to break the chemical bonds. Copper sulfate. This copper sulfate compound contains copper ion and sulfate ions that are chemically bonded, and energy is required to break the bonds. A mixture is a substance made from two or more elements or compounds but are not chemically bonded. For example, air is a mixture that contains 78% nitrogen, 21% oxygen, and 1% other gases. All these substances, they are physically together. To understand the difference more clearly, let's look at the illustration A, B, and C. In these illustrations, the circles represent atoms. The dark or shaded circles represent fluorine atoms, while the gray shaded circles, they represent hydrogen atom. Let's look at the illustration A. Illustration A contains only chlorine atoms, that is why we will categorize it into the element. Illustration B contains hydrogen atoms and fluorine atoms that are chemically bonded. That is why we will categorize them into compound. While illustration C contains chemically bonded substances, but the substances are different. And the different substances, they are not chemically bonded, they are just physically together. For example, this illustration C contains hydrochloric acid, chlorine gas and hydrogen gas. That is why the block C will be categorized as a mixture. Matter is composed of atom. An atom is the smallest particle of matter. Atom has a large central nucleus. Nucleus is surrounded by electronic shell. Nucleus contains positively charged protons and neutral neutrons, while negatively charged electrons surround the nucleus arranged in shells. Let's look at the relative charges and the relative mass of electron, proton, and neutron. Electron has a negative charge and its mass is negligible, or nearly equals to 0. Proton has a relative charge +1 and its mass is 1 EMU, while the neutron is having no charge and its relative atomic mass is also 1 EMU. Atomic number is the number of protons in the nucleus of an atom, while the mass number is the number of protons and neutrons in the nucleus of an atom. Let's look at this example. Magnesium has 12 atomic number, and atomic number is the number of protons in the nucleus of an atom. And it has 24 mass number, and mass number is the number of protons and neutrons in the nucleus of an atom. In the periodic table, the vertical columns are called as groups, and there are 8 groups in the periodic table, while the horizontal rows are called as periods, and there are 7 periods in the periodic table. Electronic configuration is the arrangement of electrons in each shell of an atom. The innermost shell is filled with electrons first and can accommodate 2 electrons maximum. The next shell can accommodate 8 electrons maximum, and so on. Let's look at this example. Sodium atom has 23 mass number and 11 atomic number. The electronic configuration can be written or drawn by using the atomic number. Let's draw the electronic configuration of sodium. In the first shell, we can accommodate 2 electrons maximum. And in the second shell, we can accommodate 8 electrons. Till now we have drawn 10 electrons. As in total we have 11 electrons. So that is why we will draw 1 electron in the third shell. We can also write this electronic configuration in numbers 2, 8 and 1. So this sodium atom has 1, 2 and 3 occupied shells. We can also count them from the written electronic configuration 1, 2 and 3. As this atom has 3 number of occupied shells, that is why its period number is 3. So the number of occupied shell is equal to the period number. Now let's look at the valence shell electron number. Valence shell electron means the number of electrons in the outermost shell. As in this atom, we have 1 electron in the outermost shell. We can also locate it from the written electronic configuration. That is why the group number is 1. So the number of electrons in the outermost shell can be used to determine the group number. Sodium belongs to period number 3 and group 1. Here we have our sodium atom. An atom is electrically neutral because it has equal number of negatively charged electrons and positively charged protons. Let's look at this example. Fluorine has 35 mass number and 17 atomic number. Number of protons can be calculated by using atomic number because atomic number is the number of protons of the nucleus of an atom. To calculate the number of electrons of a neutral atom, we will say that number of electrons is equals to the number of protons. And for the number of neutrons, we will subtract mass number from atomic number. Let's calculate the number of proton, electron and neutron of this atom. Number of proton is 17, number of electron will be 17 and number of neutron is 18, which is calculated by subtracting 35 and 17. Let's look at another example, sodium, which has the mass number 23 and atomic number 11. The number of proton is 11, number of electron is 11 and number of neutron is 12, which is calculated by subtracting mass number from atomic number. When an atom loses an electron, it becomes positively charged species called cation. Let's look at this example, sodium atom, which when will lose an electron will become a positively charged species called cation. Sodium atom has +1 charge. Let's calculate its number of electron, proton and neutron. Number of proton is equals to its atomic number. And to calculate the number of electron, we have to subtract the charge from the atomic number because this atom has lost 1 electron. So the number of electron will be equal to number of proton minus charge number. And to calculate the number of neutron, we have to subtract atomic number from mass number. So for the neutral atom, we are using the number of electron equals to the number of proton. But this charge for this charged positively charged atom, number of electron will be equal to the number of proton minus charge number. Let's calculate the number of proton, electron and neutron of this atom. Number of proton will be 11 as the atomic number is 11. Number of electron will be 10 because we have to subtract 1 from the proton number, that is 11 over there, and number of neutron is 12 that we get by subtracting 11 from 23. This atom has positive 1 charge and this has positive charge because it has greater number of protons than number of electrons. When an atom gains an electron, it becomes negatively charged species called anion. Let's look at this chlorine atom, which has 7 electrons in its outermost shell. and it needs one or more electron to complete the shell. When it will gain this electron, it will become negatively charged species called anion. Let's calculate the number of electrons, protons, and neutrons of this chlorine atom. The number of protons is equal to the atomic number, while to calculate the number of electrons, we have to add the number of the charge to the atomic number, because this atom has gained one electron. And the number of neutrons will be calculated as earlier, mass number minus atomic number. So basically we have to focus on the number of electrons. Let's calculate the number of proton, electron and neutron of this species. The number of proton is 17 because the atomic number is 70. The number of electron is 18, which is calculated by adding 17 and 1. Number of neutron is 18, which is calculated by subtracting 17 from 35. This species has a negative charge, and negative charge is because the number of electrons are greater than the number of protons in this atom. Isotopes are the different atoms of same element that have the same atomic number but different mass number, and the mass number is different due to difference in number of neutrons. Isotopes have same electronic configuration due to similar number of electrons. Isotopes have similar chemical properties due to the same number of valence shell electrons. Now please pause the video and try to fill this table. Tell your answer, and if any answer is incorrect, please go back to the specific part of the video and re-watch the video until you get the correct answers. The relative atomic mass is an average value that takes account of the abundance of the isotope of the element. Let's look at this example. Chlorine has two isotopes. One isotope is chlorine 35 and another isotope is chlorine 37. Chlorine 35 has percentage abundance 75.76 and chlorine 37 has a percentage abundance 24.24. You are supposed to multiply the atomic mass with the percentage abundance of first isotope and then add this value to the other isotope value. The other value will be calculated as same by multiplying the mass number with the percentage abundance and both values and then divide it with the 100. You will get this value 35.48 for chlorine atom. So the relative atomic mass of chlorine is 35.48. Thank you for watching. If you found this video helpful, please give it a like, share it with your friends, comment your thoughts and subscribe to my channel. Don't forget to press the bell icon so that you can never miss a video.